I'm not an engineer. I'm not an aerodynamicist. I'm not anything
Yeah.
like that. I'm just a curious person. But I do tend to take things quite seriously because, people are very quick to just tell you that you can't do it if you're not an engineer. And I get very annoyed at those things. And I kind of like almost want to just prove people wrong.
Hey, everybody. I'm Jonathan, inventor, designer, and Autodesker. Welcome to Shop Talk, the podcast series where we talk to makers, inventors, and designers from shop to shop. Today, we're talking to Tadeu Zagallo of Forza Racing. Tadeu started his project by buying a used Mazda Miata and then quickly learned Fusion to do simulation, fabrication, and bring this to the next level. He's now a professional racer with his own business making these parts and selling them. This is a really fun conversation, so let's dive in. All right. So we got Tadeu Zagallo. Did I do that right?
Yep. Yeah, that's pretty good.
Okay, good, good. From Forza Racing. So thanks for joining us, man. I'm really looking forward to this one. Um, I don't know a whole lot about cars. I'm not really a car guy, but I like pretty much all of our audience. am really interested in everything that goes into it, all the engineering and the manufacturing and everything. And you've built a really cool, business, persona, and like you've shared a lot of really cool um, media explaining how you do what you do and showing off all your little inventions and kind of innovations around this really particular type of racing you do. So I'm really excited to have you in. Could you just introduce yourself and tell us what you do and give us a little intro from your point of view?
Yeah, of course. Thank you so much for having me. Yeah, I'm Tadeu Zagallo. I'm originally from Brazil, but today I live here in Sweden, in Stockholm. I started this company recently called Forza Racing, and it's, more or less built around the race car that I was building. I'm not exactly a car guy either. I feel like I kind of evolved into that, but I'm mostly just a curious person that, bought a car and then started poking around. Um, I'm not an engineer either, so I'm, just kind of like figuring things out on both sides. I bought these like 1990 Miata back in California. I was living there for a while, and then COVID hit, and then I got bored and I had nothing to do, so I chopped it up, and I started learning everything that goes into making the car work. I rewired the whole car. I rebuilt the whole suspension. Eventually, I changed the engine. I started fiddling with the ECU, and at some point, I actually watched the video from Stanceworks with the intro to Fusion, and I started it's like, that's quite interesting, right? Like as my day job, I was a software engineer, so I kind of had that you know preference for doing things virtually instead of in real life, if you will. Like every time I had to just fabricate these little brackets or anything like that, it's not really my forte, if you know what I mean, right? Like all the grinding, cutting, it's like I figured it out, but it's not really my greatest strength. So I saw this video from Stanceworks, like, oh, that's pretty cool. And I sort of just, a regular paper printer, just drawing some simple sketches and printing, and haven't stopped since. That was maybe 4 years ago. And yeah.
Yeah, that's interesting. I kind of got started in digital fabrication the same way. I was doing it in the film industry, but I did exactly the same thing. I started by drawing things out in AutoCAD and then printing them and then, spray adhesive onto metal and then cutting it in on a bandsaw, right? And like,
Yeah.
yeah, you start doing that and then this world starts to open up to you. Well, why do I need to be the one doing the cutting? If there's this, that I'm kind of like I'm not really the best tool for this. There must be a more precise way to do it, and then it starts to open up all the other things. Yeah, that's interesting. Stanceworks was we interviewed him on this podcast last year, maybe 2 years ago. Um, but yeah, it's really cool to see digital fabrication make its way into the kind of aftermarket, racing car world. Because it's the kind of place where it's always been that this is just me being kind of a spectator. Like I said, I'm not really a car guy, so forgive me if I'm like making assumptions about stuff here. But the way I've always seen it, and the people I know that are really into cars, um, they are those people that want to go in and they want to do stuff by hand, and they're really comfortable with metalworking and welding and all that kind of stuff. But when you bring in this digital fabrication aspect, when you can leverage something like a 3D printer or a plasma cutter or, a 3D scanner, that kind of thing, um, Now it's open to people like yourself, right? A software engineer, where you
Yeah.
say, like I'm way more comfortable doing this in a virtual environment. And then when you realize how easy it is now to make that bridge from there to making the thing, now it's not just the people that are really comfortable with tools, it's people that, can become comfortable with tools over time, and it brings in more people. It's a really cool thing to see. It's also really cool to see people who are already really into cars start to get into the digital fabrication stuff. And it's like they've already got all these skills. And now they see there's this other thing that just gives them way more tools to work with and can cut down the time and like, improve precision for certain things that are maybe kind of hard to do. Do you see much of that? Like, do you have much interaction with people who were already into cars starting to get into digital fabrication?
Yeah, for sure. And I think again, like SenseWorks is a great example, right? Like
Yeah.
he's a very good fabricator and then kind of evolved into that space. Um, and I do get like, you mentioned my social media. I do mostly post around, 3D printing and the car build. And I do get some people that are just like, not happy about 3D printing. Like they'll question it, they don't like it, there's a certain resistance. But I feel like that's getting less and less. And the way I see it, it's just another tool, right? Like
Mhm.
so you wouldn't be mad at someone using an angle grinder, right? Go,
Yeah.
why do you care if I'm 3D printing? It's whatever gets the job done. And I think if you use it the way it's meant to, the way that it works, then it's yeah, just another tool in the toolbox. And I feel like it enables more people to get started. I can't begin to tell you like how many times I went to build like the simplest brackets, and then you measure and you draw and you really try to do it right, and then you go and you fit in the car. It's like the hole's off by like a few mil, and it's like all of a sudden like your M6 hole is now an M9 hole.
Yeah.
It's like
Yeah.
stretching it, trying to make it work. And it's so frustrating. And at least based on my skill set, it really changed when I got the 3D printer. You go, you draw it, you test fit, and then that's it, right? Like
Yeah.
so much easier to iterate. And now with all these services, like I know lots of people use Sen in the
Mhm.
US. We got a partner here that's very similar in Sweden called ScanCut. So
Mhm.
that another way, right? Because I personally don't have access to a plasma cutter, so that kind of limits things. But I feel like the way that things are progressing, it's getting easier and easier to have access to these stuff. So many services that you can get things cut, machined, and whatnot. So, and the price is really coming down as well, which makes it just that much more accessible.
So do you find that the resistance to digital fabrication, to 3D printing, CNC, whatever it is, does that come from an attitude that you should be sort of a craftsman if you're doing this?
That's an interesting question. I think it's, to be fair, like mostly towards 3D printing than, just digital fabrication as a whole. I think, when you post like a nice video of a CNC milling things, like I've never seen anyone get mad at that. But
Yeah.
when you post like 3D printing, I think it's, mostly maybe coming from skepticism. So,
Sure.
oftentimes we've all know how social media has gone, right? Like people don't read things. They just make a bunch of assumptions, and it's
Yeah.
like I post this video about just making the carbon fiber panels for the car, right? And they
Mhm.
are what I did is I 3D printed all these modes, and then I just, they're just modes, so they were
Yeah.
just PLA, which is uh, basically the cheapest plastic that you can print, but it doesn't take any heat.
Yeah.
It's not very resistant, so everyone is like, of course that's gonna break. It's like it's written right there, right? Like
Yeah.
it's not that's not part of the car. That's just a mode. It's not a problem.
Yeah.
So I think a lot of it comes from that. People just jumping to conclusions and
Yeah.
assuming that you're using the tool for the wrong thing.
Hmm.
When it's yeah, like I said, for me it's just another tool. It's an easy way to get things done, at least for me.
Hmm.
Um, like I feel like I've tried to get started in so many different areas. I can't imagine like I mentioned just like even like drilling brackets was challenging. I can't imagine myself like hand shaping like a foam mold for the car, right? Like that
Oh
that's
yeah.
not really something that I think I would ever do. It's just
Ugh.
very, very far from, my abilities.
Doing something like that to make it symmetrical, I mean, that's a master craftsman. I mean, it takes years and years and years to be able to do that. Also, a set of tools you probably don't have, right? You have to have these contour finders and like this. It's yeah.
Yeah, I think that's about right. Exactly. Designing Fusion, I ran through. I think the whole car for the first version, I did about 70 CFD iterations, not
Hmm.
just on the fastback, but the whole car.
Hmm.
Um, and yeah, eventually just printed it.
Yeah.
It was about maybe 7, 8 kilos of plastic.
Uh-huh.
It was also my first project of that type. It was the
Okay.
first panel that I ever tried to make, which was very questionable. Sorry, something that big.
Yeah.
Definitely some lessons learned.
Yeah.
Um,
Yeah.
and
It doesn't shrink uniformly, right? So if you're using an FDM machine, you're going to get like expansion and contraction in different dimensions based on where the layers are, right? I bet that was one of the things that became a problem.
exactly.
Yeah.
And like the shapes were very, in some areas, it was almost flat around the
Hmm.
top, but not exactly flat. So, and I printed them very thin to
Hmm.
try and save on print time
Yeah.
because I printed the whole car with a single machine. So it was trying to keep the print time down.
Yeah.
And then making them like keeping them the angle between them correct when you just have
Mhm.
like 4 mil, I think is what I printed was very,
Yeah. It's
not a
hard.
good idea at all.
Yeah.
That was tough. Ended up making a little frame out of wood underneath to support it because
Hmm.
also it was so weak because
Hmm.
it was so thin. Um, so there were definitely some challenges there, but it was a good learning experience. I feel like, the other panels definitely came out better. If
Hmm.
I had to do it over again, I probably wouldn't start with the single largest panel in the car,
Yeah.
but you learn.
Yeah. Yeah. It's such a cool idea though. I mean, it's almost like, I don't know, it reminds me of you want to print something large, right? Some large graphic, but all you have is a desktop inkjet printer. So you tile a bunch of 8.5 by 11 sheets, right? And then you have little indexes to match them up so that you actually like have the full image. It's just kind of tiled. You did the same thing with a desktop 3D printer, right? Yeah. So the process is you piece those together, you glue them together, and then you do the normal car body thing everybody else does, which is Bondo over it to get a smooth surface. And then from there, that's your formwork for a carbon fiber overlay, right? So then you
Yeah.
have this really strong, light material that makes up the fastback of the car. And in order to make it, you didn't have to have this huge mold that took up all this space and that you had to have fabricated and like this, using a skill set you don't have. You're able to just take it out of CAD and make it real, without all that. So a lot to be learned there. I mean, have people been receptive of that? Have you been, and you are selling that product too, right? You can buy the model and print that out yourself and make your own Miata fastback, right?
Yeah, that's right. We want to start selling more models. It's been uh, trying to make a business while having a full-time job and building a race car is being challenging, to put it mildly.
Yeah.
Uh, but yeah, the fastback was one that a lot of people were interested. It was like, we're gonna put it out there and see, if people really want it, they can go for it. But ideally, for the other models, we wanted to just take the time and make it easier to assemble, like, and really update them with the things that we learned, which I guess it's always a challenge with when making a product, right? Like we're just in the beginning, so every time we do something, we learn so much that it's tough to not want to go back and redo the whole thing, which is actually what happened with the car, right? Like for this year, we're rebuilding the entire car, so every single body panel is being redone, which made it tricky time-wise, but it was just we couldn't help ourselves just from it's you learn those things and it's like I need to put it back into practice and I need to make a new version and sort of fixing one thing here, one thing there, and then by the time we realized, yeah, every single body panel is completely changed.
Yeah. So the whole body. So all you've got left basically is the Miata chassis and you've redone everything.
Yeah, exactly. I think the doors are still OEM shaped
Uh-huh.
and the A-pillars, and that's all the rest is not much left.
Yeah.
These years we're also changing to bigger wheels. So the Miata originally came with like 165 tires, if I recall
Uh-huh.
correctly, on like 14-inch wheels. And this year we're running like 295 tires on 18-inch wheels because of the class rules. So they are, almost twice the width and then so much taller.
Yeah.
So whatever little bit of Miata was left had to be cut out. Uh,
Right. So did you keep the original doors because doors are so difficult to get tolerances correct? Is that why you made that decision, or is it that it just didn't matter, like the aerodynamics of the final product, those doors being as is didn't make a difference? So why bother?
Yeah, that we can't. We compete in time attack, which
Yep.
is basically everyone's on track at the same time, but we're not fighting for position, right? It's whoever gets the fastest lap of the day wins it.
Hmm.
Um, and
You're in
then like
separated
any other,
lanes and everybody's going at the same time. Is that how it works?
we're on track at the same time. It's like you're just not trying to get in each other's ways.
Okay.
Instead of competing, you're just trying to collaborate so everyone gets your fast laps in, and yeah, we share the space, but we don't really, it doesn't really matter where you are on track.
Hmm.
Um, and like any other racing, there's a rule book, and that will limit what you can do with the car or not.
Uh-huh.
And the doors are very limited because we cannot cut anything that's ahead of the door. And we also can't cut anything that's behind the door. So basically that depth is fixed. And the car is so small that we already run the exhaust inside the car.
Uh-huh.
So, and the cage is there. So basically there is not enough room to work with that it felt worth it to change. So it was
Okay.
just one less thing to do, and it's the only thing that's being kept. There are fiberglass doors that I bought all the way back in the US, but they're same shape as OEM.
Hmm. How many of the more complex things, the more complex results of whatever the conditions are when the car is going, how many of those things have you been able to sort of predict and plan for?
So that's the perhaps a little bit disappointing part, right? Because the computing resources are so intensive. I think for this year I ran something like equivalent of, I think it was 13 months of CPU times in simulation for the new version of the car.
Yep.
And that's still like just straight line, one speed, one
Yeah.
ride height. And when you
CFD
talk
is
to like,
very, very compute expensive.
yeah, and that was like I guess what we would call like a medium definition model, like a 10 million cell half car model. Um, and if you talk to people running like proper, like more high level CFD stuff, they're doing like all the different pitch angles and yaw and different ride heights, and they're doing sweeps on how pitch sensitive the car is, how yaw sensitive it is, how ride height sensitive. And unfortunately, that's not something that I have been able to do yet.
Hmm.
It's just the amount of time it takes to like prepare all these cases and how
Hmm.
long it takes to run. I haven't gotten around to it yet. I did some basic testing on different ride heights, and I do calculate things like different setups for if you feel like we need more front downforce or more rear downforce. Um, and it does help us ballpark some things. So like I think I mentioned earlier, like I'm not an engineer, I'm not an aerodynamicist, I'm not anything
Yeah.
like that. I'm just a curious person, and but I do tend to take things quite seriously because people are very quick to just tell you that you can't do it if you're not an engineer,
Yeah.
and I get very annoyed at those things, and I kind of like almost want to just prove people wrong, um, but I don't do it casually either, right? Like I didn't just download a program and I put a model through it, and whatever I got out is what I got out. I probably spent like a solid like couple thousand hours just reading. I bought the books that I could. I did some courses online.
Hmm.
I ran like so many simulations from, cases that you find online with published results to many different versions of Miata. And I can't say with like 100% confidence. I mean, nobody can with 100%, but obviously I have much less confidence than if I was a professional aerodynamicist. But I can say that, I trusted more than if I had just guessed.
Yeah.
If what was the alternative, right? I could just slap something in the car and see what
See
happens.
what happens and
And
then slap
I'm,
something else on and see what happens. Yeah. Yeah.
yeah, and then you're building all these things, right? And it's like, how do you start? Because I think for the front end this time around, I maybe tried like 20, 30 different wings for the front in all kinds of different configurations, like single element, dual element, triple element, um, all kinds of different shapes, 3D, 2D. Um, and how would I do all that, right? Like, um, even if I could like go to the track, I would have to make all these things. And also like our seasons here in Sweden, like we get 5 months to go on track,
Yep.
and the rest is winter. It's dark and snowy, and we
Hmm.
build things. And then you have all the other uh, variables like on testing things and making it accurate. So for me, at least, it's just being realistic of the tools I have and trying to make the best use of them. And obviously, the goal is always to learn. So we're going to go back, we're going to get a car on track. We're going to do some flow vis, just spray, see if the patterns match what we're seeing in CFD. We got a lot of sensors for the car, like all the shock travel, so we can check if the estimated numbers in downforce match what we calculated. And yeah, like using everything that we can that's within our means to just learn as much as we can, and see what happens, see what we can build, right? Like, I personally don't see a way that we could have done it better. A lot of the advice is just follow the best practices, do something simple, and it's most likely gonna work. I get that. I think it's quite reasonable. I'm just not that person.
Yeah.
I don't want you just, do something simple and see if it works. And maybe it's not the best way to do things, but I feel like it's the way that I learned the most.
So with the next plan, like the next phase, are you going to start to try to do simulations for pitch and yaw and all the other factors you mentioned there? Is that sort of a future plan?
Not for now yet. I probably could. That would be smart.
Yeah.
But it's just tricky because the season starts in 2 months and the car is still in the garage. So the car is built here, in my home garage, which is probably like 250 square feet or something like that.
Wow.
So we can't really tackle too many projects at once. So you have
Yeah.
to keep it moving. And the car should be on track in 2 months, and there's like lots of welding and cutting and everything else to be done. So it's sometimes just a struggle to find the time to get the next project. And we still have, so for now, like, we're not doing any simulations, we're building everything with the data that we have. So the whole car has been 3D printed again. We're testing a few different techniques. So the first time we did sort of like positive mode and then overlay the carbon. um, this time we printed the negative modes, and we're trying to do some vacuum fusion even with the 3D prints, and
Hmm.
we're going to see how that goes. So
Oh, wow.
yeah.
Interesting. Are you going to do those with PLA?
No, now this time around we printed everything in PETG.
Yeah.
Um,
Yep. That makes sense. More stable, more heat resistant.
yeah, I think the biggest downside has been the warping, as you
Yeah.
mentioned. Like, it's tricky. These are very tall and skinny parts. Like, we printed it in quite thick as well in comparison. I think the first models were like 4 mil, which was not enough by a long shot. So, and I think these are like, we tried both in 10 and 20 mil thickness. So that made it a lot easier to just assemble the model, as well as a lot stronger and stable.
Yeah.
Um, so
Yeah.
I think if we use the filament that had like a maybe fiberglass or carbon fiber, that could have helped with the warping, but then it becomes a trade-off on, cost. We were quite lucky to get a partner for all our 3D printing. This company called Ad North, here in Sweden. They have some like very, very nice Swedish made filaments. But still, like, we have to, you know, uh, weigh the pros and cons of the cost of the materials you use. It's a one-use mold, and it's about 50 kilos worth of filament. So
Yeah. 50 kilos and a single roll on a Bamboo Labs is what, 4.5?
we printed everything in 1 kilo rolls. So
Yeah, 1 kilo. Yeah, yeah. Right, right. They come in one. That's the standard one, right? The standard spool you get is 1 kilo. Yeah, wow.
yeah, we
Yeah, that
printed
adds
some
up.
3 kilos, 5 kilos, but the most common is one.
Yeah.
Um,
Wow.
we've gone to a few boxes.
I bet you have. Yeah, I mean, I don't know. There's something really interesting about being able to DIY this without being an engineer, right? It's probably the most interesting thing about these new tools we have, what kind of drew me to Fusion in the first place. What drew me to all these different kinds of tools to begin with is that this used to be singularly, it was the purview of professionals, right? It was like the software was very expensive. You in order to justify paying for it, right? And in order to justify owning the tools to do this stuff, you needed to have a degree and a day job that was going to be, consistent with this, right? But what I see happening more and more now is people like yourself um, getting into it uh, from the outside and then developing that into something else. So you get into it from the outside and you recognize your limitations, right? You're not going to design an engine, so you go talk to the guy that can do that, that can design and fabricate an engine that's going to work in your car. The skills that you recognize that you have are okay, I can learn about CFD and I can do a sort of one-dimensional forgive the metaphor there, but one-dimensional simulation on how airflow is going to work on this thing, and I can design something based on what I'm getting out of that's going to work for what I need it to do. And I think I don't know, what's interesting about it to me is that Fusion's not going to replace an engineer, right? Like you've done that. You've done this simulation for that part of it. But if at some point you really want to go all the way and you want to make sure you've got every little detail worked out there, you know, again, you can do that stuff yourself, but if you were to go into production or something like that, obviously this would need to be checked with an engineer. You give it the engineer the model. Engineer is going to go through it and go through all the certification stuff. And like, there's all these things that like, you can't like the the software product can't do that for you. It can't sign off on a design and get certified, right? But the tools are there to get you so much closer to what that end product is going to be that by the time you pass it on to the engineer, it doesn't take him forever to make it work, right? He doesn't have to work on this thing for a year to get it where you need to go. You give him something that's pretty close to there, and then he can go in and tweak things and off you go. It's something I found in architecture where, these tools are there, right? There's FEM, right? Finite element analysis is sort of the equivalent there. I know you use that for cars as well, but we were able to do that. We were able to take this tool, do some finite element analysis, and then it informs us in a direction where we can say, okay, it's going to be like this, right? I've got a pretty clear idea of what the beam and column spacing are going to be, and this special like, branching column thing here is going to be something like this, right? You hand that off to the structural engineer. And now he's got something that's totally reasonable. He can look at this and be like, okay, I'm not looking at some ridiculous fantasy from somebody who doesn't know what they're doing. It's like, okay, I can sort of finish this for them and give them something they want. And then at the end, everybody's happy, right? Um, yeah, so I mean, you alluded to this earlier, but why did you choose Fusion of all the different products you could have started with when you got into this?
I think it's always a number of things, right? When you compare something, like the amount of content online is amazing, right? Like all these tutorials, like I learned everything on YouTube. Like, before I used Fusion, I had never used any other software. Um, and like I said, right, like there's all the costs. So you search for all these options online,
Yeah,
and a lot of them are wildly expensive. And when you're looking at like building like a little bracket for your car, am I gonna pay like $1,000 a year subscription? Like it doesn't make sense, right? Like even if you can afford it, oftentimes you don't because it's unreasonable.
yeah,
And then I saw like, oh, I can get started with Fusion for free, and there's all these like tutorials online. Um, and that's I think was a main motivation to start. And then I think the reason I stuck with it for all these years was that I feel like it gives you like so many tools. Like when I started, like I said, all I was doing was 2D sketches to print. And then, slowly started doing more 3D stuff for 3D printing, like brackets and mounts. And, still like obviously the parametric modeling is so nice.
yeah.
Um, and then eventually started doing the bodywork stuff. And then you still have the form tools. So you have really like a full package that lets you basically build anything that you can think of. Um, and I feel like it's a great like all-in-one package, and it's pretty wild that it's available for free, so it's quite nice.
Cool. Well, I think now is the time to kind of segue into our little fun question we'd have at the end. So the question is, the scenario is you're in the zombie apocalypse and you got to rebuild your shop and you can get anything you want, but you put yourself at great personal risk to go get it. So what do you get first to rebuild your shop?
I guess it depends on what I already have. If I have nothing, it would probably be an angle grinder.
Angle
It's the
grinder.
most
Okay.
used tool in the shop, most
Yeah.
versatile. If I already had a computer and then I had other tools, and the 3D printer has been the tool that has given me the biggest change in my process and the ability to create more things. So I think that would be the next one.
Yeah. Have you looked at integrating metal parts with 3D printed parts at all? I've seen people
Uh,
do this before where you sort of have like um a sheet metal part that gets embedded in something that's 3D printed, and you're relying on the 3D printed part to I don't know, maybe think of it like it's got some features that key into another feature on something else, and like that part kind of locks it in, but then you're relying on the structure of the metal part. It's not something I've seen in automotive work before, and I was just curious if you'd seen that.
I haven't done it I've seen people pause the print and then they embed things like nuts,
Hmm.
so you have like stronger threads.
Sure.
I haven't tried out myself, but I have used like a just a sandwich of aluminum and 3D print
Hmm.
for things that need to be stronger. So
Hmm.
you still get the nice looking 3D print, and you can get things like if you're making a key for buttons and things like that, where you have the little like different shaped holes, and make sure that things align nicely. But behind, like you can have a backing plate for things that need to be stronger. So
Hmm.
that's to the extent I've used it, but
Yeah.
never fully emptied.
Yeah. All right. Well, thanks for talking to us, Tadeu. It's really interesting. I think the audience is really going to like this one. I learned a lot. Just appreciate your time, and thanks for doing all the cool stuff. Tell everybody where they can find you.
Yeah, you can find me there's my personal racing Instagram, which is at Zagallo Racing. And there's a company's Instagram, Forza Racing SC. And we started YouTube recently for the company, which has a few videos of building the car, as well as little tutorial on the whole process on how we built it, from CAD to carbon, as we call it, which is at Forza Racing SE as well.
Great. Thanks a lot, man.
Yeah, thanks so much for having me. It's my pleasure to be here, and of course, thanks for inviting me to the Fusion Creator Program.
Yeah.
It's been awesome getting to know all the other features on top of all the stuff I was already using. So
Yeah.
thank
Glad
you.
you're there, man. Hey, everyone. Don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things Shop Talk. If you're ready to try Fusion for yourself, find the link in our description.